Welcome to our next topic, that is Introduction to DAX. So far in Power BI, we have created our data modeling. Now we'll get to know how to write DAX functions to perform calculations in Power BI. Before going to the practicals, we'll get to know what is data analysis expressions. In this topic, we'll cover the introduction, operators, syntax, parameter naming, glossaries, functions statement, and queries. So let's move to the introduction to DAX. Data analysis expressions, commonly known as DAX, is the formula language that drives Power Pivot with DAX. We can use DAX language for Power Pivot in Excel, Power BI, Azure Analysis Services, and Tableau modeling in SQL Server Analysis Services. By using DAX, we can add calculated columns and measures to our model using intuitive syntax. So DAX help us to go beyond the capabilities of traditional grid style formulas with powerful functions built specifically to work with relational data. Before moving ahead to our Power BI, let's get to know what DAX operators we can use. To create a DAX function, we can use arithmetic operators, comparison operators, text concatenation operator, and logical operators. In arithmetic operator, we can use plus sign, minus sign, that is subtraction, multiplication, division, exponentiation also. We can use comparison operator also to create our DAX functions, that is equal to, strict is equal to, greater than, less than, greater than or equal to, less than or equal to, and not equal to. Thereafter, we have text concatenation operator using ampersand. We can use ampersand to connect or concatenate two or more values to produce one continuous text values. For example, if we have our first name and last name in two columns, then we can use ampersand to create our full name. So next one is logical operator. Here we are seeing double ampersand, which represents AND condition, where if we have given two or more conditions, then it will give us true value only if both conditions are satisfied. Otherwise, it will return false. The next one is double pipe symbol, which represents OR condition. In OR condition, we check whether any of the conditions are true. It will give the output as true. Otherwise, if both the conditions are false, the output will always be false. The next one is in conditions. It creates a logical OR condition between each row being compared to a table. For example, we can check product color in red, blue, black. All the conditions are satisfying and we are checking whether the color is in our data or not. So it will give the output as true. We can move to DAX glossary to understand each and every words or functions we use in DAX. But at the moment, our main focus is calculated column and measures. So calculated column allows you to add new formula based columns to tables. In Excel, we reference a formula based on row and column like A2 or A1, but in DAX, calculated columns refer to entire tables or columns. Calculated columns are computed at the row level and values are stored with the table. It understands row context. They are great for defining new properties based on information in each row, but generally useless for aggregation like sum, average, count, etc. We should only use calculated columns if you want to get static or fixed values to each row in a table. We should not use calculated columns for aggregation formulas or to calculate fields for the values area of pivot. We should always use measures for those conditions. Now, what is measures? Measures are DAX formulas used to generate dynamic values within a pivot table. Like calculated columns, measures also reference entire tables or columns, no A1 style or grid references. Unlike calculated columns, Measures don't actually live in the table. They get placed in the values area of pivot table and dynamically calculated in each individual cell. Measures are evaluated based on the filter context of each cell, which is determined by the pivot table layout like filters, slicers, rows and columns. Let's move to our Power BI and see how we can get calculated fields and measured columns. So this is our data in which we have created the data modeling last time, and now we'll proceed to use DAX measures in this table. So let's move ahead to our data. Here we have sales data. Let's open the data here. Now what I want to do is subtract sales amount from total cost to get my gross profit. Using this, we can get to know how much the total cost for our product is and for how much we are selling and how much we are getting the profit in that. To get a calculated column, either we can go to table tools and create new column, or we can go to column tools and create new column for calculations. But one more way is that we can right click here and go to new column and click on it. Now here our new column is created. If we do not change the column name here, it will by default get column here. We can change it by writing anything we want. I'll change it to gross profit. Now we are going to get our sales amount column, which is under sales table. For that, we have to write sales. Here it has given us the name of our table. Just press tab. In square bracket, we can select the sales amount or we can select it from the drop down. Now we got this suggestion. Either we can press tab to get it fulfilled or we can write it whole by our own. Now we'll be deducting it with our sales tables total cost. We can check the mark here or press enter to get the values in our new column. Here we can see the values is showing as rupees, but our values are in dollars. We can change the currency format from here. We will select English United States. Now our values has come in dollars. So this is how we can create a calculated column. Now let's move ahead to measures. I generally don't go to modeling and create new measure. I don't know where it is creating the new measure. Let's click here. We can see it's created in calendar table, but we don't want it here. So I'll just delete it. Now I first select where I want to create my measures, like in sales table, right click, I'll go to new measure. So here I am creating total sales. First we'll write total sales is equal to, now we'll be creating a measure using sum. I want to get sum of sales amount. How we can do that? We'll use sum function in bracket. We'll give the table name, that is sales, and the column name, that is sales amount. I'll just press tab and close the bracket. Either I can press enter or check the mark. So on the right side we can see the icon is little bit different from our data as well as our calculated column here. So our measure has been created. Now let's see the syntax of our DAX measure. Here we have given the name of our measure followed by an operator and then a DAX function. Thereafter the table and column name to perform the operation on. So there are two types of measures. First is implicit measure and second is explicit measures. We'll discuss about it in a while, but first let's move to the DAX functions. We have multiple DAX functions. First, we have aggregation functions like average, count, maximum, minimum, sum, and the next is date and time function where we can use it to perform the calculations based on dates and time. Next we have the filter function. The filter and value functions in DAX are some of the most complex and powerful and differ greatly from Excel functions. The lookup functions work by using tables and relationships like a database. Some of them are all except, calculate, earlier, earliest, filter, keeps, lookup value, remove filters, etc. Next we have logical functions. Logical functions act upon an expression to return information about the values or sets in the expression. For example, we are giving two arguments and we want to get the output only if both the conditions are true. Then there we'll use AND function. And when we'll be using only one of the conditions should be true or both of the condition can be true, then we can use OR function. We'll use all the functions one by creating measures.